h connected. You have to get a common denominator by multiplying by exact factors. So if it has an a plus h, great. Doesn't it need an a? So I multiply by a over a. Questions on that? This one needs an a plus h over a plus h. True? Now the whole point of getting a common denominator is so you can just focus and combine my terms on the numerator. So in the numerator I have a 3a minus 3a. Now look right here, negative 3 times h, so you have a minus 3h. So in the numerator, doesn't 3a minus 3a go away? Yes. So you have negative 3h all over a times a plus h. That is just this piece. Then you have divided by h over 1. So now you can go ahead and say, because I have one fraction divided by one fraction, dividing fractions is easy as pie. Flip the second fraction and multiply. So aren't I looking at this? So then from there, when multiplying, you multiply straight across, and you can divide out exact factors across the multiplication sign. So all my h's divide out. So on top you have negative 3 times 1, which is negative 3. And then on bottom you have a times a plus h. And that is your final answer. Now understand, people have been asking me, is the bottom okay like that? And is it okay in standard form if I distributed a through? Yes, they are equal, right? One is not better than the other. Both are equal. Questions on that? Was it a lot easier than some of you made it out to be? Do you see where you made your errors? Okay, awesome. Let's try again. Let's try again. Now before we try the next algebraic problem, I need to make sure you understand how functions work. Everybody look. If I gave you this function f of x and said find f of 2, what do you do with the 2? So that would be 2 squared plus 1, which would simplify to be 4 plus 1, which is 5. Okay, well if you know how to do that, then how do you do f of x plus 8? Just like with the 2, don't you plug in x plus 8? So that's x plus 8 squared plus 1. True? Now if I needed to, couldn't I distribute and combine like terms and stuff? Yeah, awesome. If I said find f of x, what would you say the answer is? Okay, if you knew how to do all of those things, then you should not freeze when I give you something like this. Take the function, plug in x plus h. Then subtract off the function when you plug in x. Does everybody see? Divided by h. You're just simplifying this. Everybody get what to do. Just plug it in and simplify. Take the function, plug in x plus 8. Do you know how to do that? Then subtract off f of x from that. And then divide that all by 8. Yep. I see you have a lot of recycling. I know, right? I need to pick it up. Hey, everybody up here. So, everyone, it says find the function when you plug in x plus h. So, that means I take x plus h and plug it in there. So, that would give me this, the blue section. X plus h squared plus 1. And it says subtract off f of x. So, I'm subtracting off entire f of x. Does everybody see? Then it says divide by h. So you'd say, okay, to simplify this, I need to be able to combine like terms in the numerator. To do that, I need things in standard form. I am not going to break the most forbidden of all forbidden math rules and just square that, square that. That would be really, really bad. I did that. So if we have x plus h times x plus h, then we have a plus 1, don't we? Then we have distribute the negative, minus x squared minus 1. To multiply this out, you would do x squared. Plus xh plus xh. That would be plus 2xh's. Plus h squared. Then we still have our plus 1 minus x squared minus 1. This is just the numerator. This is the top. So now we have an x squared minus x squared. We have a plus 1 minus 1. So on top that leaves plus h squared all over h. A lot of you, are you seeing where you made your error? Third time's going to be a charm here in a second. Then on top, we'll factor out an h. So if we do that, then we divide by h, leaving me with 2x plus h. And then on bottom, we have our h. And so then our h's divide out. So our final answer is 2x plus h. Do you see where you made your error? Okay, good. Awesome. Hey, try again. Guys, this time get it right. Try again. If you got it wrong, get it right. Okay, good. A lot of you got it right. So I'm going to just talk for the video. If you already got it right, yep, you're good. Just sit there quietly. Okay, so distributing this out correctly to combine like terms on top, I would need to do 3 times x plus h times x plus h, wouldn't I? And then I'm going to distribute the negative 2 through, so that'll be minus 2x minus 2h. Then distribute the negative through, so it'll be minus 3x squared plus 2x. Then I got to distribute this stuff together, so I'm going to distribute my x plus h's together. So I have 3 times x squared plus 2x h's plus h squared. Right? Then I'll distribute my 3 in. So I have 3x squared plus 6x h's plus 3h squared. Then I still have minus 2x minus 2h minus 3x squared plus 2x. This is just all the numerator. So now combining like terms. When you combine like terms, what do you get on top? You said, what, sorry, say again? 3h squared plus 6xh, sorry, minus 2h, because these canceled out. That's all over h. Then on top, we can just factor out an h. And then we're there. Okay, awesome. Okay, awesome. Most of you were able to get it right, guys. Okay, good job. Way to go. All right, so let's get to the lesson now. Actually, one more for safekeeping. Okay. Now, I want to look at this one together first because a lot of people have some major misconceptions algebraically about this problem. Okay. It says take the function and plug in 3 plus h. So, to do that, wouldn't I take 3 plus h and put it there? So that becomes 3 plus h to the negative 1. All agreed. Okay, let's move on. It says subtract the function when you plug in 3. So I'll be taking 3 and plugging it in there. So wouldn't that be 3 to the negative 1? All over h. Now everyone listen very, very carefully. Look, if I have an x to the negative 2, it is appropriate to say I want to not have negative exponents, so I can take the base and flip it over a fraction, 1 over x squared. Now if you look back at this though, there's a subtraction sign. If there's a subtraction sign, you can't take this and flip it down right here. Because that's like breaking the forbidden rule. You're flipping over a subtraction sign. Do you see the problem? So instead, what you're going to do is fix the negative exponent, but you've got to flip it over itself. You can't flip it over this fraction, but its own fraction. So instead, we've got to flip it over itself. So you take that right here. So that would be 1 over 3 plus h, do you guys see? Minus, flip this over itself, 1 over 3, all over h. Do you guys see the difference? Very important algebra knowledge there. Continue to simplify that. Go. Did you guys get it? Should have been just a negative 1 though. Because you got to make sure to distribute the negative. See how it's 3 plus h to both. Okay. Hey, if you did not get this answer, write it down, make a note, retry it later, get some help. You guys have no choice to be able to do this level of algebra. Alright, way to go though. Okay, everybody, I need you to listen so that you can know what to be prepared for this worksheet, okay? So, this stuff is hard. Algebra is hard. That's why algebra fails people in calculus, not calculus. So understand, I would not do it if I thought it was too hard. It's hard, but not too hard. So why am I doing this? Because calculus algebra is hard. We need to practice to be ready. Now understand, you are going to start doing some of these really hard ones down at the bottom of the worksheet, notice. problems 49 through 60, you're not going to get them right the first time. So what you're going to do if you do not get the correct answer when checking it online is just try again. It's really too hard to find your error. Try again, be more careful the next time. Alright, here's the point though, do not give up. If you get it wrong twice, then you might want to say, I'm going to go have Ms. Christensen watch me do this problem. I'm not going to go over it for you, but I'll watch you and say, oh, you just made your algebra error right there. Does that make sense, everybody? Alright, now understand, if you do not keep your work nice and neat, you're going to get lost in the problem because there's so much going on. So just plan on giving yourself 1 page per problem on the hard one. Alright, so this is my cute little saying. It's not how many problems you can get done in an hour that counts, it's how many hours to a problem that counts. Okay. Alright. Good stuff. That's good philosophy.
Except for when you take in, the ACT.
Everybody, I just want you to watch this part of the lesson. So here are just some errors involved that we see with algebra, then we'll start on the homework. You're going to have this time and next time, please watch. Yeah, I know, I have something weird going on. Error. Okay. Okay, so everybody looking here, can you see with the light on? Or do I need to turn it off? Okay. What error was made here? This student says these are equal. What did they forget to do? They didn't distribute the negative. Shouldn't it be minus x plus b? Alright, awesome. Moving on. Another error is people break the most forbidden of, and I should not see anyone at this point in my class break this rule from here on out. Do not square that. Oh dear. Okay? That is the most forbidden rule. Next thing is, focus people. People will factor out, they'll look at this and say, I can factor out a half. What they're mistaking it with is this. A half A plus a half B does have the ability to factor out a half and then left with be A plus B. But this is multiplication. With multiplication, you can't factor things out. Instead, we just reorder it. This would be a half times a half times A times B. Do you guys see? A fourth AB would be correct. So don't be mistaken there. Okay, next mistakes I see. Okay, so we have 3x plus 6 squared. What I see people do is they say, well, there's 2 terms and there's a 3 in common. So I can pull out a 3, divide by 3, so then left is x plus 2 squared. Now what they're doing is technically almost correct. They could factor out a 3, but wasn't the 3 squared? So it's actually like this, isn't it? They're all squared, yeah? So that would be 9x plus 2 squared. That would be appropriate. But also, if I asked you to multiply that out, wouldn't it just be easier to just multiply it out? Yes. Probably. Okay, next thing is errors involving fractions here. People think you can split apart a denominator. X plus b is a factor that cannot be split apart. If this was opposite, you can't split apart numerators, you cannot split apart a denominator. So if we reverse this and had an x plus b over a, it is appropriate to do x over a plus b over a. Does everybody see? It is not, however, appropriate to split apart a denominator. Next thing is, people cannot flip a fraction and multiply correctly. So always write your ones. This is b over 1. So dividing fractions is easy. If I flip the second and multiply, shouldn't my 1 be on top, my b be on bottom? People think you can just add straight across, but I don't think we're at that. I don't think we're going to have people do that in here. What do we have to do? Get a common denominator. Couple more errors, we'll get into the worksheet here. This is important. A third x people think is 1 over 3x. So watch. 1/3 x is 1/3 times x over 1, isn't it? When we multiply fractions, we multiply straight across. So wouldn't that be x over 3? You guys see what they did? I don't know what people do here. I have no idea why anyone, this is what the book says calculus students make. They say that they go from here to here. I don't know why anyone would ever do that. This is over 1, isn't it? We would need a common denominator, x over x. So that would be 1 plus 2x all over x. Okay. Okay, this is huge, guys. A lot of you still do not know your properties of exponents well enough to be successful on this worksheet. So listen for the last time. Here. We have a base raised to a second power, raised to a third power. That is the rule. Raise a power to a power and you multiply. You do not add them. So it should be what? X to the 6. Now people will mess up that rule with this next rule. Do I need to kick some butt out there? Or so we have the same base. Focusing. We have the same base. When you multiply, you add. People multiply, and that's not how it works. When you multiply, you add. This should be x to the 5th. Okay, good. We have a 2x to the 3rd. People will think both 2 and x are to the 3rd. If it's like this, it's 2, and then times by x to the 3rd. Agreed? Okay. All right, next thing is, this is huge. Huge. We just saw this. If we have this, we can't just flip that down, flip that down. We just saw that you cannot do that, everybody, right? Very important. So instead, if you saw this, you would have to rewrite it as 1 over x squared minus 1 over x cubed. And then to put it together, you would need a common denominator. Make sense? Awesome. Moving on. Okay, errors involving radicals. If we have the square root of 5x, people will say, okay, well, that's the square root of 5 root x. But isn't it really root 5 times root x? They're both under a square root. You can't bring 5 out. Okay, I'm telling you right now, this is one of the most made errors in Calculus 1. The square root of x squared plus a squared equals x plus a. Heck no. Which rule just was broken? Equivalent to the forbidden. I used to not understand why I couldn't do this. Well, I understood why I couldn't do x plus a squared. So I should have been able to understand x squared plus a squared raised to the 1/2 power, which is the same thing as the square root. We know we can't just square that. So you can't just 1/2 that and 1/2 that. Does everybody see? That's the forbidden rule. So this doesn't simplify, you guys. That is that. There is nothing you can do with that. Make sense? All right, then under here, you can't just pull out the negative out of the square root. You can factor it out of the terms, but then it would be left underneath. All good? We're not going to be dealing with i's, though. Okay, next thing, errors involving dividing out. What happened here? They divided across an addition sign, didn't they? Can't happen because bx was also divided by a. It would be appropriate to go like this. A over a plus bx over a. So that would be 1 plus bx over a. But you got to keep them both divided by a. So here, what should I do? A out of the top. And then left would be? 1 plus x over a. Very good. And then take out the a. Okay, good. We're almost there. Errors involving dividing out. What should this have simplified to be? 1 plus what? 1 over 2. The x is divided out, but left on top with a 1, right? Okay, so now here's the thing, guys. This is going to seem weird to you. You're not going to understand why today. That's not the point. In calculus, there are times when you're going to write things in an equivalent but different format. You're not going to be asked to do that because you're going to say, well, why would we do that? That's not what we're learning today. We're learning how to see things in equivalent that are equivalent mathematically just in different forms. So everybody look at this. This is called unusual factoring. If we have 5x to the 4th divided by 8, is it equivalent to write it as 5/8 x to the 4th? Are you just saying no because you think, like, did you even look at the problem?
Yes.
How do we multiply fractions, people? Straight across. So let me ask you again. Are they equivalent? Yes. Okay, yes. Okay, they are equivalent. So basically, what do? They pull out a 5/8. Isn't that okay? All right, moving on. So what do they do down here? Are they these equivalent statements? Very good. Yes, it's the same principle. I heard somebody say they pulled out a 1 on top and they pulled out the -6 on bottom. And that is equivalent. Yes? Yes. Alright, unusual factoring. Now, if I said to you, factor out a 2, you'd be like, well, why? There's not a 2 in common. You're right. But if I asked you to do it, could you do it? Yeah, so if I said to you, make there a leading coefficient of 1, you'd say, I have to factor out a 2, don't I? Yeah. Well, when you factor something out, what you've done is you've divided it out of each term. So then left in your parentheses would be x squared, wouldn't it? Minus 1/2 x right? Minus 3 halves. They're equivalent mathematically. Agreed? Okay, great. Alright, looking at this, if I said to you, rewrite this with a negative exponent, is it appropriate to bring this x to the third to the top?
Yes.
Yep, and write it as a negative exponent. All is good here, right? Equivalent. Yep. So then, if this and this are the same, isn't this and this the same? Yes, what we have is 7 over 2x minus 3 to the 1/2 power. Well, that's true. I can make it a multiplication problem, bring this up, and now it has a negative exponent. They are equivalent mathematically. Good? Are you good? Good. Sweet! Okay, if I said to you, write this fraction as a sum. Instead of a fraction, I want this just to be a sum. You'd say, okay, well, I got to bring this root x, which is x to the 1/2, out of the denominator. Can't I do that by bringing it up? But if I bring it up, wouldn't I need to put it with each piece? Yeah, because they're all divided by that. So do you see how they have the x and then times x to the negative 1/2? Then they have a 2x squared times x to the negative 1/2 for the bottom thing. And then 1 times x to the negative 1/2. They're equivalent mathematically. Agreed? All right, right here, would it be appropriate to split up the denominator? Nope. But can I split up a numerator? Yes. Yes, so that's good. All right, inserting factors and terms. Now understand, you're like, well, why are you doing that? That's not what I'm asking you to do. I'm asking you, are these mathematically equivalently the same? 2x minus 1 to the third, is it equivalent to 1/2 times 2x minus 1 to the third times 2?
Yes.
Yes, isn't a half times 2 1? They are the same. Okay, awesome. Are these the same?
Yes.
How do you know? Right here, wouldn't you flip and multiply? Giving you 4 9 x squared. Wouldn't you take this one forward, flip and multiply, giving you negative 4y squared? Yeah? Alright, now I'm asking you, can I do this? There are times in calculus when you will learn this in calculus though. You'll learn when you would do this. So right now I wouldn't expect you to just know to do this. But you'll insert random factors and terms. That makes the problem easier to work with for the calculus part. So here's the thing, guys. If I wanted, notice I have x over x plus 1. If I wanted, could I add 1 then subtract 1 to the problem? Yeah. Have I changed the problem if I've added 0? Isn't adding 1 and subtracting 1 adding 0? Yeah, well then why might I do that? Well, because then can't I split apart the numerator? So how did they split apart the numerator to get this? So they did x plus 1 over x plus 1, you said. Good, minus 1 over x plus 1. Do you guys see how she's splitting it up? To get to the 1 minus 1 over x plus 1. So you would say yes, they are equivalent mathematically. All good? Very good. Alright, now we're to the homework. Here we go. The rest of my examples are coming off the homework. Number 7 is, it's not crossed out. Okay, everybody, here's what it's saying. The answer is not correct. Why? So let's read the instructions. It says, describe and correct the error. So it's saying these are not equivalent. So a student said that a times x over y is equal to ax over ay. That is wrong. It's telling you it's wrong. But why? What algebra mistake did they make? What did they do with the a? Didn't they say, oh, we need to distribute to the top and bottom? And guess what? There's like 80% of you out there that do that half the time. I've seen you in here. It doesn't distribute to the top and bottom, does it? So you say they distribute to top and bottom. Now it says to correct the error. So shouldn't we, to correct the error, show our work? We'd say, well, that's a over 1 times x over y, which is equivalent to ax over y. We've now answered both pieces. Describe the error, correct the error. Make sense of that section of what we're doing. Okay, let's do number 9. Which rule did they break? Why don't you just wait to see what I assign before you complain? Okay, anyways, what did They do. Yeah, they just square rooted this, square rooted this. I call it breaking the forbidden rule. Isn't that the breaking the forbidden rule? So I'm just going to write that. Yeah. No. This is the main, this is the forbidden of all forbiddens. So then what is the correct answer? Well, there's nothing we can do here, correct? So that is the correct answer. All right. Let's do 17. Describe and correct the error. So what did this student do? Right, so didn't they just add straight across? What the heck is the student doing? They added straight across. Yeah. Added straight across, which is incorrect. So now to do it correctly, you said you needed a common denominator. So let's do it. So this would need y over y, x over x. So in our numerator, what do we get? Very good. All right, I can see on number 12 very clearly what this student did. Can you? What'd they do? They divided across, done addition sign, didn't they go? Oh, sixes. That's dividing across addition. So you say divided across addition sign, which is bad news. So there's nothing we can do to simplify that, correct? Look at the problem. What would we do? There's nothing we could do. You see? Okay, then that's the answer. Easy, right? Easier than you thought it was going to be? Alright, so now let's go to the next section here so you understand how to do each section. Okay, it says on 19, insert the required factor. That means make these equivalent statements. So it's just looking and saying, basically, what did they do? Yeah, but so they factored out a 1/5. Do you guys see? So if they factored out a 1/5 from here, then left would have been 3x plus 2. Your answer is 3x plus 2. It's that simple to make them equal. Okay. Let's look at another one. 21 on my key is wrong. I made an error. Let's look at it. What did they do? They pulled out a 1/3. When you factor something out, I'm going to go back and do the math. Don't we divide by what we factor out? So left in our first term, dividing fractions easy as 5 flip the second and multiply. So won't that become what? 2x squared. Good. Plus next term, won't my 1/3 divide out? So plus x. Now right here I wrote plus 5, and a lot of people put plus 5/3. So it's actually plus 15. Dividing fractions is easy as 5 flip the second and multiply. How can you check if you got it right? Distribute the 1/3 in and see if you end up back at the top, right? So not super hard, right? Okay. Alright, now let's go to 41, next section. Let's read it. It says, write the expression using negative exponents. So let's look at this first piece here. To write that instead with negative exponents, don't we just have a 4/3? And then we have an x to the... What's the exponent? There you go. Does that make sense? Awesome. Okay, let's move to the next one here. We have a plus 4, and then we have an x to the negative 4, right? All right. So then we have a minus 7x, and then guys, isn't this 2x to the 1/3 on bottom? So what would it be on top? 2x, you got to put it in parentheses because both 2 and x are under a cube root, so both 2x to the negative 1/3. We have now answered it. Write the expression with negative exponents done. Does that make sense? Okay. Awesome, and now we're to the big Oh, never mind. This one's still the easy one. Okay, 43, it says, write each fraction as the sum of 2 or more terms. It's basically saying split this up into multiple terms. You can do it however you want. It says write it as 2 or more terms. So don't we know that we can split apart a numerator? So let's just call that 16 over x minus 5x over x minus x squared over x, which simplifies to be 16 over x minus 5 minus x. And now we just split it apart into 3 terms. It said 2 or more. So that's good. One way of doing it. Pretty easy. Agreed? Okay. And now that leads us up to be able to do a problem such as number 50. All right. Now here's the key, guys. Math, this is where you are going to see, like, literally this kind of thing is what made me go into math. I got it wrong so many times, but when you get it right, it's just this, it's the best feeling. So understand, it's going to take some being careful. Okay, so everybody, you got to think when you do these problems and not make algebraic errors. And if you are really careful, it's really not as bad as it looks. So first of all, the key is keeping your work beautiful. So everybody look what I do. I see how there's like kind of different sections here. I simplify in sections. That's how I do these big hard problems. So let's focus in sections here. First of all, do you see how we have a subtraction sign right here? And we see we have negative exponents, don't we? Is it appropriate to take that and flip it right there? No, because of the subtraction sign. Do you guys see? So instead, we do need to flip it, but don't we have to flip it over itself? Yeah. So let's just focus on section 1. If you keep your words gorgeous, it's a lot easier. So I'm going to call this section 1. So now look at what you do have on top, everybody. You have a negative 3. That's not a negative exponent, so it's going to stay on the top, right? Then you have an x to the 5th, don't you? Cross them out as you go, maybe. And then, don't we also have a 2x to the positive 1? So that's also on top, 2x. Now this gets flipped over that stuff. So we flip it and we have an x squared plus 1 to the 4th. I'm still in section 1. You can tell it took a lot of convincing. Hey. All right, I'm going to napkin to sit on. Sprint. Okay, keep going with section 1. How would that simplify? Look at the top. What is the top? No, that top simplifies way more. Multiplying together. Can't we reorder multiplication? So negative 3 times 2 is negative 6. X to the? X to the 6. Very good. All over x squared plus 1 to the 4th. Now I have people just start going nuts and start distributing this out. Don't distribute unless you need to. Stop there. Stop. Isn't that as simplified as it gets for the most part? Okay, now moving on. You go on to section 2 now. Let's go on to this section. Now notice we have a negative exponent. We can't flip it here because once again of the subtraction sign. So in section 2 here, we would, everything with a positive exponent will stay on top, so don't I have a 5x to the 4th? Yes. But now I do need to flip that, so now I have over x squared plus 1 to the 3rd. Okay, so section 1 minus section 2. Let's write that together. Here's section 1. Subtract section 2, which is 5x to the 4th, divided by x squared plus 1 to the 3rd. So it's actually not that bad, is it? And then that's all over x to the? Good, x to the 10th. Now you'd say to yourself, I cannot, so I have all over x to the 10th right now, but I can't flip that until I have one fraction on top. So don't I need to get a common denominator? Yep, this has 4 x squared plus 1, this one has 3, so we only need one more x squared plus 1. Do it to the top and bottom. Now you keep in mind your goal. You said, I got a common denominator so I can combine the numerator. So I'm going to star it so we focus on just the numerator for a second. So I have a negative 6x to the 6, right? Distributing. So that's minus 5x to the 6. Negative 5x to the 4th times 1. So minus 5x to the 4th. Let's keep combining like terms in the top. Don't just look at them and say negative 1. I have so many people do that. Think. Negative 11 x to the 6 minus 5x to the 4th, and that was all over the common denominator of x squared plus 1 to the 4th. And then we still have divided by x to the 10th. But now we're to the point where we actually can do divide the x to the 10th part. I hate this computer sometimes. So we have divided by x to the 10th over 1. So dividing fractions is easy as 5 flip a second and multiply. So we have 1 over x to the 10th, don't we? All right, now you say to do this, to simplify this, I need to factor out my x to the 4th on top, don't I? Does everybody see where I'm at? Yeah? Okay. So on top here, because we know we multiply straight across, so on top here, I can pull out an x to the 4th, and because there's a negative in front, I'm going to pull out negative x to the 4th. So divide by negative x to the 4th. Divide by negative x to the 4th. So then left in my first term is positive 11x squared, isn't it? And then we have plus 5. And then that's all over x squared plus 1 to the 4th times x to the 10th. And our final step is at hand. Now can't I divide out those x to the 4th and x to the 10th? There's 4 x's on top and 10 of them on bottom, which would leave me with how many x's where? What is wrong with my computer? Okay, good. 4 of them divide out, there'd be 6 here. So write out your final answer on your paper in its own separate box. Negative, left on top was 11x squared plus 5. On bottom we have our x squared plus 1 to the 4th, and then we have our x to the 6th, and we're done. It looked harder than it really was. Once you start putting things in format, in the right format, flipping negative exponents and stuff, it's usually just getting common denominators and stuff. Okay. We're only going to do one more example, and then the rest of the time will be yours to work. We have a lot of time in class. Let's do one more together. Admit, that wasn't as hard as a lot of you thought it was going to be. No, it wasn't, Josh. You're so dramatic. No. He's so dramatic, isn't he? Okay. 54, write the problem down, let's do it together. Everybody listen, this is such a good question. A lot of people see this and they ask, should I switch it to square roots, which is such a valid question. Here's the thing, guys. With algebra, fractional exponents are always better. You can always do better algebra with fractional exponents. So let's leave it as fractional exponents. Okay, let's go in sections. With this section, there's nothing we can do, right? We can't just 1/2 that, 1/2 that, so there's nothing more. So section 1 is done. Moving on to section 2 here. Good, that needs to become x plus 2, and then you flip that, so that would be all over 2x minus 1 to the 1/2. Do you agree? So section 1, 2x minus 1 to the 1/2 minus section 2. That's what we're looking at. It's always better to have everything together as one fraction instead of 2 separated fractions. But to add fractions, what do we need? Common denominator. So you would then go over here and draw a 1. What's the common denominator? Okay, let's write that. So we're multiplying by 2x minus 1 to the 1/2. 2x minus 1 to the 1/2. Now the whole point of that is so we can combine the numerator. Now watch how beautifully this ends up simplifying. I have so many people see this and they think it's 2x minus 1 to the 1/4. When you multiply the same base, you add, not multiply. What's a half plus a half? 1. So that just became 2x minus 1 to the 1. Well, wasn't that nice? Then we still have minus x plus 2, this is our numerator. So let's keep going with the numerator. Do you guys see why I did that? So now that's just 2x minus 1 minus x minus 2. So combine like terms in the numerator. 2x minus x is x minus 3 all over the common denominator of 2x minus 1 to the 1/2. Now technically that's your final answer because there's nothing more we can do except for I do believe that that would be considered not an appropriate answer because technically we have a radical on bottom, don't we? So everybody look, you say this is x minus 3 over the square root of 2x minus 1. You say, well, that answer is not appropriate, so I'm going to rationalize my denominator now. So you multiply by the square root of 2x minus 1, the square root of 2x minus 1. So our answer would be x minus 3 times the square root of 2x minus 1, like that, all over 2x minus 1. Now you're going to probably see it as a fractional exponent instead of a radical, but it's the same thing. That answer is equivalent to, if you were to put x minus 3 times 2x minus 1 to the 1/2, isn't that the same? All over 2x minus 1. Okay, awesome. That was not that bad. So really, guys, they're really not that bad as long as you know your algebra. Alright, awesome. Let me tell you what problems you need to do. Everybody please listen carefully because every year there are like 10 students who do it wrong and I make them reorganize and it's hard. So listen, this is what's required for the homework over the weekend. You will only have 15 problems to do at home. There are considered 5 sections. Section 1 are these problems. Section 2 are these problems. Section 3, 4, and 5. Those are the problems in each section. You are to choose 3 problems of your choice from each section. So let's count. 3, 3, 3, 3, 3. That's 15 problems, everybody. Does everybody see? Does that make sense? You will just choose. You are not allowed to choose any problems I have done as examples. So with that being said, you need to choose 3 additional new problems from each section. Guys, half of these sections you're going to get done in 5 seconds. Remember how easy those first 2 examples were? So it's really not that much homework at all. Here's what section you need to really focus on over the weekend and get them right. Okay? This section down here with the really hard ones towards the bottom, as you can see, problems 49 through 60, those are the ones that's now taking in, seeing if you can do algebra, the advanced algebra I'm looking for. I'm going to put 1 to 2 problems of that level on the exam. You've got to know that stuff. So notice I've done 2 of these down here. Which ones did I do? Okay, so those are not options. Those are the 3 you would do for sure. Does everybody see? Okay. Now any of those others you can choose. I just put those because I thought those were good ones. Because those are kind of the easier ones, to be honest. Okay? But you can do any of those. So understand, I am going to allow you to do additional problems for bonus on any test of your choice. Any test of your choice for this quarter. So here's what you can do. Now listen carefully because I always have people put the bonus and the assignment together. Not correct, I will make you redo it. You need to do your 15 problems called the assignment, the calculus algebra assignment. That is going to be due, you'll hand all that in. On a separate section, if you choose to do additional problems, then you can get for 1% for 5 problems. So that adds up to be around 4 to 5% if you were to do all of them, if that makes sense. So what you can do is, in a separate place, say bonus problems, and then just show me your work. And I will go like this. 1, 2, 3, 4. Oh, 5, 1%. Does that make sense? But I'm going to look and see if they're right. If you have a bunch of gibberish and wrongness, you're not going to count that. Okay. Now the bonus ones need to come from this section, 39 through 70. Because the other ones are just too easy. No. It's like, yeah. Alright, so you have this time and next time to work on that. But that doesn't mean you can't do homework. You need to come next time with the 15 problems done. I'm going to have you hand in the 15 problems at the beginning of class and after that it's late. Does that make sense? Because I don't want to give you, I want to give you an additional day to work in class so that if you worked your butt off on these 3 and you just cannot figure it out, then you can hurry and ask me. Does that make sense? Alright, then next time also, then you can be working on bonus next time in class. That's huge. I don't have to do that. I could just start on the next unit. In fact, other teachers are doing that. They're just starting on the next unit. I want to give you opportunity to get some extra bonus. and to get really good at algebra. So, ready, go.